This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs.
Next, we have a sequence of duo talks. The first is Dan and Doug, Dan Kamen and Doug Rotman, Dan from UC Berkeley and Doug Rotman from Lawrence Livermore Lab. And they are going to talk about the important issue of scaling, especially what we can do at the level of UC, the state, to national and international. Dan?
Very good. Well, once again, thank you all for hosting this and for the incredible work that Ram and everyone else has done. You really did keep the team moving. And as one of the deputy directors, it's been a real pleasure to look at a lot of the results and to talk with the teams. And I think you'll see a lot of the lessons that we've been learning from the other teams in this chapter going forward. And so we have, once again, a really exceptional group, but also with a very large group of people we want to acknowledge who provided input and weren't directly in the author group. And they come from not only the UC system, the national laboratories, and a number of the business Silicon Valley Business Group and others, LBL and Livermore, all in the team. So it's really been a pleasure to do this. And Chapter 4 is really the ultimate cherry picking. It is what are the great lessons, not about individual technologies, practices on the economic or behavioral side, but what does it take to scale things up? And that's really where California as a system, not just the university, not just the labs, not just the business community, is really this exciting laboratory, and that's really why we're all here. And so if there really was one high-level conclusion, it's that very different than the 1960s, where the system was the problem. The system is really the solution. And what we find over and over again in looking at different cases is that you need a dose, or maybe a big dose, of research and development. You need a big dose of deployment. You need a big dose of understanding the markets. But it's really putting all of these things together and linking together what the government does in terms of setting that agenda, what the university system does, what the labs do, and what very creative, forward-thinking businesses do. That's really the critical picture. And again, when we see that full ecosystem, then we do see solutions that scale across the state and scale beyond. And the cases that crash and burn are ones where we don't get that healthy interaction of all of the units. And so this is an iconic picture in the solar field. And we heard from Scott, not looking just at solar, but this is the evolution of different solar technologies. And it's meant to be a blinding blur of different technologies on their own individual innovation paths. This is their efficiency over time, lots of different actors, many from the UC system. That R&D investment's critical, but then was what we heard before. We heard it from Dave from the Energy Commission. We heard it from people earlier in the morning, talking about this learning curve, this learning by doing process, where we consistently see for technologies that we can mass produce, and there are some interesting cases where we don't mass produce, that we often see this 20% decline in prices for every doubling of production. And that is an observation, not a basic law of economics. Max will be able to correct anyone who says it's a fixed rule, but it highlights this path that's brought solar, as just one example, way down in price to the numbers that you heard, 4 cents a kilowatt hour for some systems when it was over 50 recently. That's part 1 and part 2 of a process that we see, and Chapter 4 highlights across many cases. And then there's deployment. And so California's million solar roofs is one large-scale example. We'll talk tomorrow about some quite ambitious goals to think about targets beyond that now that California is halfway to that million solar roof goal by 2020. We think the numbers could be actually bumped up quite a bit. But off-grid, developing country energy services for the poor is another whole market. And the lighting products you see off-grid on the bottom were actually the highlight of an event at the White House on Thursday, highlighting the many, many companies, both California, US, and more broadly globally based, bringing initially glorified lighting systems with cell phone charging and now very efficient refrigerators and TVs, building up a very large ecosystem of technologies. It's when you get all of these pieces together where we find the successes. And when you break down, that's really the warning for the group. If you don't get all of that together, you really don't get it. Examples of thinking holistically, interdisciplinary about these different issues come in many forms. There was a very important workshop that took place at Irvine earlier this year. So we have some authors on the project that were the chairs of it, but the lessons were very, very similar. To think about the water-energy nexus, the carbon embodied in water based on its movement, that we need to think about institutional arrangements so we can gather the data across very different modalities, finding ways to develop metrics that look at energy used to move water, water required for energy, impacts on ecosystems, fish, community groups. There's a whole variety of things where we need to consistently be looking out of the comfort zone of individual small groups, whether it's an individual researcher or teams that think kind of similarly. And so finding ways to build those enabling ecosystems so that the system really can be the solution is a critical part of the story. As we think more broadly about it, here's an example tool, and there's a number of groups in the state at both research groups that are not at universities like E3, to university groups at Davis, at UCLA, at Berkeley, and I'll just highlight one example from Berkeley where an energy system modeling tool is utilized to think about how to provide highly robust, reliable energy that meets our environmental and economic cost goals. And this is a project that started off with state support for California, expanded to the WEC, the western part of North America, and now there are versions of this particular modeling tool available for all the countries you see here. Chile, Nicaragua, we're working on Mexico, China was recently released, East Africa, the data is being gathered in parts of Southeast Europe, and the lesson is very interesting. These are all different scenarios with different mixes of technologies with nuclear in purple, biofuels, as you just heard in the previous talk, here in green, coal in brown, we have hydropower in blue, gray is gas, and then red geothermal, yellow solar, and light blue wind. All of these cases meet that 2-degree goal by 2050. But the challenge is, you see, if we're not efficient, we're going to need more energy, no surprise. But all of these cases get there. So while technology enables a whole bunch of paths consistent with California's goals, there are critical branch points and there are social decisions that the hardware options don't answer. And that's that broader ecosystem of actors. Which ones are better in terms of ecological impacts, in terms of enabling communities, large and small, to generate the energy they need. And if we jump from this picture of the least cost scenarios in 2020 to those in 2050, we see scenarios such as my own personal favorites, the ones where we have greatly decreased solar costs, but also greatly decreased storage costs, things that many people are working on in the system, and our regulators are setting mandates to get storage in the system. We also have cases where if nuclear meets some of the price numbers that have been talked about of carbon capture, all of these meet those targets, but this is not a process that's going to be solved by technology. It'll be enabled by technology, but only solved by us thinking about what are our goals. The carbon goals, the water goals, the job creation and environmental justice goals. Just to kind of highlight the many other cases where this comes up and to point out some of our current failings, we have important issues, as I've just highlighted, for energy, the water case as well, where we need metrics that stretch across not only energy and water, grams of carbon emitted per amount of energy or amount of water delivered, but also effects on biodiversity and communities. We have similar stories in transportation, where the low carbon fuel standard we mentioned before is a great example of building a framework around metrics, even when those metrics are hard to use. An amazing thing California did, quite different than the European roundtable on sustainable biofuels, is when we came to the really challenging issue of what are the indirect land use impacts of biofuels, California didn't run. This European Commission essentially defined that outside their purview, whereas we took it directly on board. California at the Air Resources Board and now at the US EPA are grappling with the really hard question of what is the indirect land use impact of biofuels. And you've got to do that heavy lifting to get there. And that's, again, enabled by California legislation, supported by the research community to really make that story happen. Environmental justice is an area where many groups are focused, but arguably we could use some strong goals. And I do know, because I wrote it, that a question that'll be asked tomorrow of Senator Pavley will be, what are some of the features in SB 32 that we didn't have in AB 32 that we would need to really make it a socially and demographically equitable program, something that we could definitely improve upon from our first effort. And again, this amazing article from the New York Times that many of you have read and are teaching from that kind of show the excesses of home design and community design that don't follow these practices. That is a recipe in what not to do, and it's one that took place in our backyard. So we are far from perfect on this, as we all know. To highlight moving the tools further, many of you we talked about this morning, and President Napolitano, my own Chancellor Dirks have all highlighted their role in the Cool Campus Challenge. That started out as an Air Resources Board project supported by groups like Next 10 and others, and it's an effort where we are looking back and forth at how can consumers, from businesses to individuals, really get a handle on what are their carbon footprints. So we have an interactive calculator, and when you go to the site, what everyone does first is, of course, put their own zip code in. You can roll your mouse over it, and you can see what the carbon footprint is, averaged over your zip code, and then do your own footprint and see, are you better or worse than the Joneses? And that's what everyone does first. Great lesson of behavioral economics. We're not so good at absolutes, but we're quite good at knowing are we better or not than our neighbor. So we need to utilize those types of tools to move along the process. And so, in terms of the data that's come out of this, this is carbon dioxide emissions from households by zip code. And again, that's the map you can roll over and see not only the fraction of energy that comes from fossil fuel sources, but also the amount that you get kilowatt hours a year, natural gas, fuel oil, the housing budget, and then transportation, goods and services. And when you zero in on cities, something that you see that's kind of remarkable is look in detail, and many of our cities that have won huge awards for being green are cities that have solved the problem or have taken advantage of what's going on in the urban center, but have not dealt with the suburbs. And so thinking more holistically is critical to that process overall. And so as we think through these kinds of issues, we can utilize these tools, and all the campuses are engaged in this challenge. We're giving out awards to cities that are taking advantage of these processes. And this is really a way to bring what we're all working on the research and governance side as an opportunity to work community by community and challenge ourselves to do better. And Doug Rotman will highlight more of how the campuses are moving this along.
Thank you. Thanks, Dan. And as we think about scaling, what we're thinking about is how to scale up our influence and scale up those deployments out to larger and larger areas. And critical to that are going to be partnerships, as we discussed before. Partnerships include those between campuses and labs. Secondly, we see very, very strong partnerships between the UC and state entities and federal entities. And finally, the all-important aspects of making sure the industrial partnerships are there, because they will be the ones key to making those deployments happen. But in the UC area, we have really, really lucky in that we have golden nuggets of innovation already ongoing at these campuses. And I have just highlighted a few here. Each campus has their own, but just to bring out a couple. Right here, how many went to the San Diego microgrid tour? It was really, really fantastic. We spent some time out there. We saw that within campus, they are already generating 85% of all their demand on campus here. Really fantastic. And they have now linked that with a very strong and large test bed of energy storage devices. Very, very excellent. Right next to all of their smart grid area. And that, I think, is going to be a test bed and for people to come try out new ideas and bring this thing to larger and larger scales. They've combined those two right next to each other, and they are now becoming a real avenue of expertise. And how do you combine production with storage to offset that demand, increase the efficiency, as Scott mentioned, like that? That's really, really powerful. And what you're seeing is, because of that kind of capability at these campuses, manufacturing locations are bringing their jobs and bringing their skills near these campuses. There's a solar manufacturing site nearby, creating jobs. It's that sort of research, that sort of test bed, and that sort of manufacturing ecosystems that can really help branch out these solutions across to the larger and larger scale. Again, how many people have gone to UC Davis West Village? Really great, great place. If you have never been there, please do visit. They have 2,000 people on staff, on site. They're living. This is a real living laboratory now. They are producing 4.1 megawatts. 82% of all their energy use is by renewable means on site at that West Village. Really, really important showcase here for how deep energy efficiency can really play a deep role. They made a big study in their West Village of just how much can you drive down this efficiency area. And they were able to, in a place where people are living all the time, they have found ways to achieve 50% more efficiency out of living these areas than the California code now handles in its own. So this is a showcase of how you can do this in a living laboratory, people living there, all the lessons learned. They're now expanding that out into anaerobic digesters for waste and fuel from that, smart lighting and EV car charging, many, many different aspects. They're bringing this out to a larger scale. And to the point that now folks from around the state, around the nation, around the world are coming to Davis to analyze what they're doing. Can we learn from that experience and bring that out to the rest of the world? Finally, in LA, as many of you know, I forget the exact number, but a very large percent of all the energy used in the United States and the world are in urban settings or mega cities. They are really the crux of where you can establish huge energy savings and sustainability avenues. And UCLA has taken on a huge task. They are now partnered with LA, and they have 3 goals in this partnership. One, they want all 100% of energy used and transportation used in the city of LA to come from renewable resources. That's all of the energy used and all the transportation used in LA. That's a very, very large task. Next, they want all of their water use to come from LA sources. 100% of water come from LA sources. And finally, you want to do this all within context of a very sustainable, rich, wonderful ecosystem of plant life and biodiversity. That is a very, very large task. And they have over 150 faculty now working on this, doing great work. The next thing is a 5-year plan coming out soon, and to full deployment out by 2050. But those are 3 examples of the rich innovation that's going on at these labs that we can scale up to larger and larger regions. We heard this morning about the great work from UCOP in working with industry to bring 80 megawatts of solar online in the state. That's a great example of how the UC leadership can drive this forward in a larger and scale-up way. And UC Merced is one of those recipients of that, and they are now ramping up their renewable on-site plus this UC resource in the Central Valley. They may likely become the first UC campus to be carbon neutral well before 2025. It's an example of on-site renewable, purchased renewable, and biofuel renewable fuel cells. So this is really example. Those again are expanding our scales out to the state and out to the nation. So we've talked a little bit about these partnerships, and these partnerships are really, really critical. As we said many times, campus lab, and then campus industry. All these things are very important. For those are the ones that are going to really drive innovative science and research at these campuses, building the next generation of energy ecosystem people and building the next scale of sustainable solutions. We also really think these intersectoral partnerships are going to be really important. Can the federal and the state governments get together with the UC to drive these solutions on a really large scale across the nation? I'll jump down. Maybe this could be done by achieving uniform goals. Put out some really large stretch goals of renewable energy generation cost of any types. We don't need to be prescriptive here. How about energy technology performance goals? Or how about technology performance goals? Or any of these things, that's going to be, put out these large goals and let these teams of campuses and labs and industry and federal and state governments form these consortiums to achieve those big, big goals. We think about the DOE Sunshot example, where they put out a bogey of a price, and that now then coalesced enormous amounts of people in industry and universities working together. And again, I want to stress over and over again the importance of these industrial partnerships. They are the ones who can help us deploy those themes out on campus or elsewhere. Working in these partnerships, working with industry, and putting forth these large-scale, big task-driven goals, we think we can achieve these kind of scale-ups on the state and the national and the global side. This should be probably the largest scale-up that one can imagine, if we can actually engage from the United States, UC, into the California, all the way out to the UC bilateral in China. That would be a monumental achievement for the state. Thank you.
Okay, we'll take some questions. First, I want to make a comment. I want to illustrate what Doug was just doing. Here he is bragging about what's happening at 3 campuses, didn't say a word about his own lab, which is also doing some terrific work. So here you have an example of taking ownership of things that are happening at the UC system. Wonderful illustration of partnering and the fact that this is a team effort. So let's have some questions for Doug and Dan.
So we talk about, California and the UCs and so on as kind of, driving innovation and coming up with all kinds of good technology solutions and so on. But at the same time, right, it doesn't make too much sense to come up with innovations, but then economically make it kind of impossible for a lot of developing countries and countries without resources to be able to actually adopt these innovations. So can you comment on how you think we should make a lot of the innovations that come up here in the UC and in California accessible to a lot of countries that may not have the means to do it themselves?
So first of all, it's a great question, and second, there's certainly no single answer to it. But a number of the partnerships that we've seen are certainly opportunities. And when I kind of briefly did that solar example, the idea was very much that it wasn't just we innovate on solar through this scale of basic R&D to the manufacturing to deployment and do it in California or in the United States and then hope there's some trickle down. Many of the innovations we're now seeing with pay-as-you-go technologies to allow us to use information technology so that you take that solar panel home in Kenya, where I showed those pictures from, or Nicaragua, or wherever else. Those are innovations for which UC researchers partnering with the Department of Energy, the International Finance Corporation, often the governments of those countries, are critical. And in fact, the biggest off-grid energy workshop is taking place, co-hosted by researchers from the California State University System, Department of Energy, and the International Finance Corporation in Abu Dhabi today. And so it is a place where this is very much a two-way street, and it's really why we mentioned those market opportunities. That said, your question is still right on, because there are many, many valleys of death in this technology development, and there's many more of them in developing countries. And so some of the opportunities to get the community at the Paris Climate Conference excited about this opportunity to see partnerships from our university system all the way to small tech NGO groups in developing countries, that's one of the ways. There is a plan to develop a $100 billion fund that will enable us, although it's very much underfunded to this point. We're also seeing partnerships at the subnational level with the governors under 2 MOU, and that's subnationals around the world. So no simple answer to a big, deep question, but we certainly see tendrils, and no question this team-based approach is part of it. But the question goes much beyond what we can sort of do right here. But great point.
I'll just add one thing. We heard about it a little bit this morning, but in concurrent phase to this initiative, President Napolitano also has an initiative with Mexico. So here's one example where UC is stepping up to bring these kind of skills to our friends in Mexico and bring their students here. That exchange, I think, is going to be another way that we can expand this influence and scale this up.